Hi, this is Mrs. Basin. I'm going to review number 2 and number 3 on the average atomic mass practice sheet. So on this first one, it tells us there's 3 isotopes. So this is the first one, this is the second one, and then we want to know the mass number of the last one. So we're going to use average mass equals mass times abundance plus mass times abundance plus mass times abundance, because there's 3 of them. So the first one has a mass of 23.9850 and an abundance of 78.99, plus the second one, 24.9858, and an abundance of 10. And then the third one, this is the one I'm looking for, so this is going to be X. And then to get that abundance of the third one, we know that all the abundances total 100. So if 100% is my total, if I subtract out the 78.99, subtract out the 10, that gives me 11.01% as the last abundance. So that's where that number comes from. The other number that's kind of confusing is where to get this mass number. So for this one, this average atomic mass is the mass from the periodic table. So this number is what we're going to use as our average mass, so 24.31. And then all of this gets divided by 100. So then what we're going to do here is multiply both sides by 100, and that gets rid of this. Then I'm going to multiply these together, add them, subtract them from both sides after I multiply the 100 times the 24.31. So then I'm left with 287 equals 11.01 times X. Okay, so I moved all of this to the other side and subtracted from this. That's where the 287 came from. And then this 11.01 times X, that's what that is. Then to solve for that, I'm going to divide both sides by the 11.01, and then that gives me my X value, which is 26.07 AMU. Okay, so once you get it set up, it's pretty much a giant algebra problem where you're solving for X. For the second one, it's a similar process. 2 isotopes here. So I'm still going to do average mass equals mass times abundance plus mass times abundance. Average mass, I'm going to get off the periodic table. So chlorine is 35.45, so that's what goes here, just like we did in the previous problem. The first mass is 34.9689 times abundance plus 36.9659 times abundance. Okay, now this one, we don't know either one of the abundances. So we're going to use this abundance is total 100. So if I make the first one X, then the second one I can make 100 minus X. That way I don't have more than one variable. So then, again, we're going to divide all this by 100. So same deal here, where I'm going to multiply both sides by by 100. So this is 3,545 equals 34.9689x plus 3696.59 minus 36.9659x. Okay, so remember when you have this has to be distributed. Okay, then I'm going to combine like terms. So I'm going to get all of my x's together and all of my things that don't have variables together. So then what that gives me is a negative 151.59 equals 199.7x. So then once I've done that, now all I have to do is get x by itself. So I'm going to divide both sides by 199.7. And this ends up, because of that negative, that actually ends up being negative over there. So this is a negative 199. So the negatives go away. So I end up with x equals 75. So that means my first percentage, my CL35, is 75%. And then to get the other one, CL37, that's going to be equal to 25%, because I know they have to total 100, just like what I did up here. So again, this last one, this is like a bonus level one. But again, once you get it set up, it's just a big algebra problem. So remembering that the abundances total 100. So if one of the abundances is x, the other has to be 100 minus x. That way all you do is solve for x. Remembering to distribute those, combine all your like terms, get x by itself, and then subtract from 100.